Very good evening to all. Audio video clear? Audio video clear? So today our topic is NFA with Epsilon moves. NFA with Epsilon moves. So first we will see some example. After that we will see some theory. So see, we have a one NFA with Epsilon move. Now we have to find what is the language accepted by this. What is the language accepted by this? What is the language accepted by this? So see, my dear friends, this is the infinite tape. These are the cells. It contains A. In finite control, we have initial state Q0. In Q0, when we read A, change state Q1, change state Q1. Whenever Q1, on the Q1, we cannot read anything, and we can change our state as Q2, as Q2. So A is accepted, A is accepted. Now see, double A is accepted or not? See, double A is accepted or not? Initially we are on the Q0. Whenever we read A on Q0, it changes state Q1, and Q1, we have two choices. Either we read A or we read nothing. So whenever we read nothing on Q0, then we can change our state as Q2. Or Q2, we cannot read anything, and we can change our state as Q0. Q0. On Q0, when we read A, this A, we can go to our state, next state Q1. On Q0, we cannot read anything and change state Q2. So this is all. This is also accepted. So it means it can accepted any number of A's, excluding epsilon, any number of A's excluding epsilon. So the language is accepted by this is A ki power plus, A ki power plus. Clear? Clear? Now see the next example. See the next example. On Q0, we read A, Q1, B, epsilon, Q2, C. So what is the language accepted by this DFA? What is the language accepted by this DFA? The DFA nahi. What is the language accepted by this epsilon NFA? A star, B star, C star. Okay? A star, B star, C star. Now see transition function. See the transition function. Please listen carefully. In DFA and in NFA. So what is the transition function in DFA? Q cross sigma determines Q. Q cross sigma determines 2 की power Q. Here we read only one input symbol. Here we read only one input symbol. It does not have capability to read a string. So whenever we read a string, then we need another transition function that is known as delta cap. It is a extended transition function. Extended transition function. Extended transition function. Extended transition function. So how to write for this? Delta cap for this, q cross sigma star determines q. Q cross sigma star determines 2 की power q. Suppose we have a DFA, this one. Q naught A, Q1 A, Q2 A, Q2 A. So if I read this one, Q naught triple A. So this is the right notation. If I write like this, this is false notation. This is false notation. This is false notation. Because delta does not have capability to read a string. So how to write this? See. Delta cap Q naught on triple A. This is equivalent to delta cap, or we can please listen carefully. First you read this string. So delta cap Q naught AA, delta cap A, again this divide into this Q naught on A, this. So what is the output of this? The output of this is Q. Whenever we read A on Q naught, we goes to Q1. Then Q1 A del this. So Q1 on A, we goes to Q2. Then Q2 on A, we goes to Q0. So the output of this is Q naught. Whenever we read a triple A on Q naught, we goes to Q naught. Clear? So this is the extended transition function in DFA. See next example. Suppose we have any string by belongs to sigma star, x belongs to sigma star, and a belongs to sigma. Y equal to xa, then what is the extended transition function on any state q y? So we can write like this as delta cap q xa this one. This is equivalent to this one. Okay, Bhargava, T Bhargava, very good yaar, very good. So this one is clear, how to write this extended transition function in DFA. This is clear, my dear friends. This one is clear. This one is clear or not? Yes. Extended transition function in DFA is clear or not? Okay, now we'll see extended transition function in NFA. See, we have a NFA Q naught on A goes to Q naught, and Q naught on A goes to Q1. Q1 on A goes to Q2. Q2 is our final state. So this is a NFA. If you are in second year, then you are not able to write a gate examination. If you are in second year. Okay. So see, my dear friends, suppose we want to read a string A on Q naught. Then what is it? What is it? So first you read Q naught A, then Q naught on A, see, there is a difference. It returns set of states. It returns set of state because this is the NFA. We can read a input symbol and goes to zero, no states, one states, or more than one states. So it returns set of states. So what it will return? It will return Q naught Q1. So we have to find this one, or this is the set notation. This is a set notation. This is a set of states. So first you find Q naught on A, then Q1 on A. So again this is a set. Again this is a set. Yes, you can try for GATE 2024. Clear? Clear. So this can be written in the form of set notation. Set notation. So I will write for you in terms of set. In terms of set. So how to, please listen carefully, how to write this. See, delta cap Q naught on A union delta cap Q1 on A. So what are the states here? Q0, Q1. What are the states here? Q2. So the final output of this is Q0, Q1, Q2. So we can put here delta cap Q0, Q1, Q2 on A. So again you find out the Q0 on A, Q1 on A, Q2 on A, and make the union of these three. Make the union of these three. So this is the delta extended transition function in NFA. In NFA we have some properties. So please see that properties, that is very important properties. That is very important properties. First, definitely you crack and score the good rank. See, delta cap on some state q on x, if it is equivalent to delta cap on this. What do you mean by this? Whenever we read a string x on q, it goes some state, and whenever we read a string y on q, it goes on the same states. So they goes on the same set of states, So this is the state q. So on this, when we read a string x, we go to like this state, and whenever we read a string y, we go same state. So this means this. So now, please, it implies that delta q xz is same as this one. This is same. Clear? Now, see another point. Whenever, when two strings are equivalent, note, when two strings are equivalent, when two strings are equivalent. See the example. We have this NFA A, B, Q2, A comma B. So when we read a string A, it end with Q0. Whenever read a string AA, it end with Q0. Whenever read a AAA, it end with Q0. Whenever we read AB, it end with Q2, ABB and Q2, ABA and Q2. So these strings are equivalent. Sir, how to find this? Dear, whenever we read a string from initial state, please listen carefully. Whenever we read a string from initial state and it push the finite automata on the same state, then we can say those strings are equivalent. Whenever two strings start with initial state and they possess finite automata on the same state, then we can say strings are equivalent. So when we read a string A on Q0, it pushes NFA on Q0. Whenever we read a string AA, it pushes finite automata on Q0. So these two strings are equivalent. Is it clear? Bhargava, theory of computation is going on, and you can see the operating system by Pankaj Mishra sir and compiler also. Clear? So from this, is it clear? Equivalent of two strings. Equivalent of two strings. Is it clear? Yes, is it clear or not? Okay. So see, one property that is known as right invariant property. What is the right invariant property? See, first x and y are equivalent, x and y are strings, x y belongs to sigma star, x and y belongs to sigma star. They are equivalent if and only if when we read a string x from initial state, it pushes finite automata on the same state as this when we read a string y. So these two x and y are equivalent. X and y are equivalent. X and y are equivalent. Clear? And y are equivalent. Now see what is the right invariant property? What is the right invariant property? If x and y are equivalent, it is implies that xz equivalent yz. It is equivalent yz. This is the right invariant property. Right invariant property. Right invariant property. Right invariant property. So see one question on the based on the right invariant property. This type of question is not asked till now the GATE examination, but in future definitely this type of question they asked. See, assume 011 is equivalent 100. Then which of the following is true? Then which of the following is true? Then which of the following is true? Option A, option A, 011 1 is equivalent to this one. Option B, 011 110 is equivalent to 100 110. Option C, 10011 is equivalent to 10100. D, 1011 is equivalent to 1100. So which option is true? Yes, this is the complete course of TOC. This is the complete course of TOC. So which of the option is true, my dear friends? Which of the following option is true? See, These two strings are equivalent. So see first option A. This is suppose X and this is Y. This is Z. This is Z. So we can apply here right invariant property. So this is true. This is X. This is Z. This is Y. This is Z. So this is also true. We can apply here right invariant property. This is X. This is Z. This is Z. This is Y. So we cannot apply here right invariant property. Same here. This is Z. This one is X. This one is Z and this one is Y. We cannot apply right invariant property. There is nothing like that left invariant property. Left invariant property. Okay? Are you getting my point? So only option A and B is true. A and B are true. Only option A and B are true. Now, come to the epsilon NFA to NFA conversion. Epsilon NFA to NFA. Yeah, we can say NFA with epsilon move and output. Suppose we have algorithm, give input NFA with epsilon move and it gives output NFA without epsilon moves. NFA without epsilon moves. NFA without epsilon moves. Clear? So we have this example. Q0 on A, epsilon Q0 1 on B, epsilon Q2 C. So what is the first step? Find out the epsilon closure of each state. Find epsilon closure of each state. Sir, why we have to find epsilon closure of each state? First, you know what is the epsilon closure. Set of states reachable from reachable from given state by applying any number of moves. This is the epsilon closure. So why we have to find the epsilon closure of each state? See, what is the epsilon closure of Q? See, what is the epsilon closure of Q? See, my dear friends, without reading anything on Q0, we can go on which states? We can go Q0. Without reading epsilon, we can goes into the Q1. Without reading epsilon, we can reach also in Q2. So this is the epsilon closure of Q0. Or we see here, please, this is your input tape. Initially you are here and initial state is Q0. You without reading anything, you can change your state as Q1 without reading anything on Q1, because you have two choices, either you read B or you read epsilon. You can change your state Q2. So these are the epsilon closure of Q naught. Similarly, find the epsilon closure of Q1. So we can stand only Q1 or goes into the Q2. Q2 on epsilon, only Q2. So these are the epsilon closure of Q0, Q1 and Q2. These are the epsilon closure. Sir, why we have to find the epsilon closure? To find the final states in NFA. Which states are final when we convert epsilon NFA to NFA? So see, those states epsilon closure contain final state Q2. So they are final states in equivalent NFA without epsilon move. So Q0 is also final, Q1 is also final, Q2 is also final. Or we can say, when we read a epsilon and we can enter into the final state, so that state make a final state in equivalent NFA. Clear? Clear? So now second step. Find out the number of states in NFA without epsilon move. So see my dear friends, how to find Q0, Q1, Q2 on A, on B, on C. So Q0 on A. What do you mean by this? We can read any number of epsilon before A. We can read any number of epsilon after A. So if we have to find Q0 on A, so see, Q0, what is the epsilon closure of Q0? Q0, Q1, Q2. Q0 on A, Q0, Q1 on A, phi, Q2 on A, phi. What is the again epsilon closure of, because on Q0 we can read any number of epsilon. So what is the epsilon closure of Q0? Q0, Q1, Q2. What is the epsilon closure of phi? Phi. What is the epsilon closure of phi? Phi. So Q0 on A, union of all these states. So whenever we read A on Q0, it goes to Q0, Q1, Q2. Now similarly we find Q0 on B. So what is the epsilon closure of Q1? Q0, Q0, Q1, Q2. Q0 on B, phi. Q1 on B, Q1. Q2 on B, phi. Epsilon closure of phi. Epsilon closure of Q1, Q2. Epsilon closure of phi. Union all these things. So whenever we read a B on Q0, we goes to Q1 and Q2. Now Q0 on C, we can read any number of epsilons before C. we can read any number of epsilons after C. So Q naught on epsilon. What is the epsilon closure of Q naught? Q0, Q1, Q2. Q naught on C, phi. Q1 on C, phi. Q naught on C, Q naught. Q2, sorry, Q2 on C, Q2. The epsilon closure of phi. Epsilon closure of Q2, Q2. Union these states. So Q2. So whenever we read a C on Q naught, it goes to the Q2. Similarly, my dear friends, we can find on Q1 on A. So when we find a Q1 on A, transition function Q1 on A. So before A we can read any number of epsilons. After A we can read any number of epsilon. So what is the epsilon closure of Q1, Q2? Q1 on A, phi. Q2 on A, phi. Epsilon closure of phi. Epsilon closure of phi. So when we read A on Q1, it don't have any transition. Now next Q1 on B. What is the epsilon closure of Q1? Q1, Q2. Q1 on B, Q1. Q2 on B, phi. Epsilon closure of Q1, Q2. Epsilon closure of phi. Union all these states. So this is Q1 and Q2. Now Q1 on C. Epsilon closure C. Epsilon closure Q1, Q2. Q1 on C, phi. Q2 on C, Q2. Epsilon closure of phi. Epsilon closure of Q2. Union these. So Q1 on C, it goes to Q2. Clear? Now Q2 on A, phi. Please calculate this. Q2 on B, phi. Q2 on C, Q2. Okay. So this is the corresponding or equivalent NFA with given NFA with it is equivalent NFA to this given epsilon NFA. So what are the states are final? Okay, I will calculate Q2 also. See here. Q2 epsilon closure A epsilon closure. What is the epsilon closure of Q2? Q2 on A, phi. What is the epsilon closure of phi? So here is phi. Q2 on B. Epsilon closure of Q2 is Q2. Q2 on B, phi. Epsilon closure of phi. Q2 on C. What is the epsilon closure of Q2? Q2 on C, Q2. Epsilon closure of Q2. So when we read a C on Q2, it goes to the Q2 state. So what are the states are final in this equivalent NFA? States which contain final state in your epsilon closure, those states which contain final states in their epsilon closure which are final states. So what is the epsilon closure of Q0, Q1, Q2? It contains Q2, so this one is final, this one is also final, this one is also final. So this is the equivalent NFA for the given epsilon NFA. It is the equivalent NFA for the given epsilon NFA. Clear? Clear? We'll see next example. We'll see next example. Convert NFA without epsilon move. Without epsilon move. Q0 up 0 Q1 0, 1 0 or you, this is the Q2 and this one is Q3 1. So find out the equivalent NFA without epsilon move. Without epsilon move. Please try to solve this. After a couple of minutes, I will solve this question for you. See, first you find the epsilon closure of Q0. The epsilon closure of Q0 is Q0, Q1, Q2, Q3. Yes or no? Q1 is present or not? Q1 is present or not? Sorry, Q2 is present or not? Q2 is present or not in the epsilon closure of this one? Can we reach here without with only reading epsilon? No. So Q2 is not present in the epsilon closure of this. So Q0, Q1 and Q3. Now, what is the epsilon closure of Q1? Q1, Q3. Q2 is not present because we cannot reach Q2 by reading nothing on Q1. Next, epsilon closure of Q2. Only Q2. What is the epsilon closure of Q3? Only Q3. So when we convert equivalent NFA, then what are the states are final? Q0 is final, Q1 is final and Q3 is final. Now convert into equivalent NFA. Q0 on 0. Q0 epsilon closure 0 epsilon closure. Q0 on what is the epsilon closure of Q0? Q0, Q1, Q3. Q0, Q1, Q3. Q0 on 0, Q0. Q1 on 0, Q2. Q3 on 0, Q3. Epsilon closure of Q0, Q0, Q1, Q3. Epsilon closure of Q2, Q2. Epsilon closure of Q3, Q3. So Q0, Q1, Q2, Q3. On 1, on 1, on 1, on 1. Q0 epsilon closure 1 epsilon closure. Epsilon closure. What is the epsilon closure of Q0? Q0, Q1, Q3. Q0 on 1, 5. Q1 on 1, 5. Q3 on 1, Q3. Epsilon closure of 5, epsilon closure 5. Epsilon closure of 5, 5. Epsilon closure of Q3. So Q0 on 1, it goes to Q3 only. On Q1, Q1 on 0, Q1 on 0, Q1 on 0, epsilon closure 0, epsilon closure. Q1 on epsilon, what is the epsilon closure of Q1? Q1, Q3. Q1 on 0, Q2. Q3 on 0, Q3. Epsilon closure of Q2, Q2. Epsilon closure of Q3, Q3. So when we read a 0 on Q1, it goes to Q2 and Q3. Q3. Clear? Now Q1 on 1. Q1 on 1. Epsilon closure 1 epsilon closure. What is the epsilon closure of Q1? Q1, Q3. Q1 on 1, 5. Q3 on 1, Q3. Epsilon closure of Q 5, 5. Epsilon closure of Q3, Q3. Union this. Q1 on 1, it goes to Q3. Now next Q2. Q2 on 0, 5. Q2 on 1. See. Q2 on 0. Epsilon closure of Q2, Q2. Q2 on 0, 5. Epsilon closure of 5. Epsilon closure 5. Q2 on 1. What is the epsilon closure of Q2? Q2. Q2 on 1, Q1. What is the epsilon closure of Q1? Q1, Q3. Q2 on 1. Q1, Q3. Similarly for Q3. Q3 on 0, Q3. Q3 on 1, Q3. What are the states are final? Q0 is final. Q1 is final. Q3 is final. This is the equivalent NFA. This is the equivalent NFA. Clear? Clear? So, my dear friends, this is all about the epsilon and NFA with epsilon move, NFA with epsilon move, and how to convert epsilon NFA to equivalent NFA. So now remember this thing. Finite automata divide into two categories. Without output, these are known as acceptors. In this we have seen three categories: DFA, NFA, epsilon NFA. The power of these three are equivalent. So we already we discussed these three part. Clear? Now next part is finite automata with output. With output. This divide into two categories: Murray machine and Millet machine. The expressive power of both machines are same. In next lecture we will see finite automata with output generator, with output generator. This is also known as transducer. Transducer. This is also known as transducer. Clear? Take one example for HW. Please try to solve itself. Convert epsilon NFA into NFA. So this is Q naught on 0 goes to Q naught. When we read epsilon, it goes to Q1. It goes to Q1. On Q1, when we read a 1, it push finite automata onto Q1. Next, Q2, without reading anything, we goes to Q2. Next, Q3. Convert this epsilon NFA to NFA without epsilon move. Without epsilon move. Clear? So today lecture is over. If you have any doubt, please ask me. In next lecture, we will continue finite automata with output generator. With output generator. So have you any query? Please ask me. Yes. Okay. Thank you so much. Shubh Ratri. Jai Mahakal. Jai Hind. Jai Maa Bharati.